Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 11. The question is, a particle of mass m is confined to a box of unit length in one dimension. It is described by the wave function psi x is equal to square root of 8 by 5 sin pi x into 1 plus cos pi x. For x equal in between 0 and 1, and the wave function will become 0 outside this interval. So we need to calculate the expectation value of energy in this state. 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section quantum mechanics, and the concept involved here is one-dimensional potential box. So in the given question, there is a particle of mass m which is confined to a box of one-dimensional box of unit length. The wave function is given as psi x is equal to square root of 8 by 5 sin pi x into 1 plus cos pi x. Now the general wave function for one-dimensional potential box is psi nx is equal to square root of 2 by L sin n pi x by L. So here L is the width of the box. Now in the given question, here it is mentioned that the box has unit length, that means L is equal to 1. So if you put L equal to 1 in the general wave function, it will become psi nx is equal to root 2 sin n pi x. Here the given wave function, you can see that this is not matching with the whatever wave function is given in the question. The general wave function and the given wave function are different. So what we can do is, first we have to convert this given wave function to a general wave function form. So how to do that? First of all, we will omit the bracket and write down the expanded wave function. So it will become psi x is equal to square root of 8 by 5 sin pi x plus square root of 8 by 5 sin pi x cos pi x. Now if you look at, so you can see that this wave function is a sum of two wave functions. So now the first term is matching with the general wave function expression, though the coefficient is not matching, but overall form is matching. Now second term has a cosine term which is not there in the general wave function formula. So first of all, we have to omit this cos pi x term. So how to do that? What we can do is, we can use a trigonometric formula, that is sin 2 theta is equal to 2 sin theta cos theta, which implies half of sin 2 theta is equal to sin theta cos theta. So this formula we will use in this expression in the second term. So this expression will become psi x is equal to square root of 8 by 5 sin pi x plus 1 by 2 square root of 8 by 5 sin 2 pi x. So this will become sin pi x cos pi x will become half sin 2 pi x. Now here in this expression both the terms have sin term. Okay. So it is somehow matching with the general wave function term, but the coefficient is not matching. In the coefficient is for unit length, it is root 2. So what we can do here is, here instead of square root of 8 by 5, we will take out root 2 from this. So instead of square root of 8 by 5, we will write square root of 4 by 5 into root 2. So ultimately this will become psi x is equal to square root of 4 by 5 into root 2 sin pi x plus 1 by 2 square root of 4 by 5 root 2 sin 2 pi x. Now here you can see this root 2 sin pi x is the wave function for n equal to 1, that is ground state for one-dimensional potential box, and this root 2 sin 2 pi x is for n equal to 2 first excited state of the 1D potential box. So as you can see, the given wave function is a combination of two wave functions, that is a combination of first that is ground state and the first excited state wave function. So this will be psi1 and this will be psi2 according to the general wave function formula. So finally we can write psi x is equal to square root of 4 by 5 psi1x plus square root of 1 by 5 psi2x. See, what will happen here is there is already 2 here and root 4 will give 2. So 2 will get cancelled. Ultimately there is 1 by 5. Okay. So this is the final expression we have got for the wave function according to the wave function of the 1D potential box. Next, our question is to calculate the expectation value of energy in this state. So now we have come to a form terms of the wave function according to a solvable term. Next is to calculate the expectation value. First we have to check whether this wave function is normalized or not. So the normalization check is done by multiplying the complex conjugate of the wave function with itself. So this will be equal to square root of 4 by 5 psi1 star x plus square root of 1 by 5 psi2 star x into square root of 4 by 5 psi1x plus square root of 1 by 5 psi2x. So this psi1 and psi2 both are orthonormal wave function. That means psi1 star psi1 and psi2 star psi2 will be equal to 1 and psi1 star psi2 and psi2 star psi1 will be equal to 0. So ultimately the product will give 4 by 5 plus 1 by 5 which is equal to 1. That means this given wave function is a normalized wave function. Now let's calculate the expectation value. So first of all, we have, when you calculate a wave expectation value of energy, if you have a given wave function of the form of psi x is equal to a psi1x plus b psi2x, the expectation value of energy will be equal to a star a E1 plus b star b B2 E2. E1 and E2 are the energy corresponding to the ground and the first excited state. So here A is square root of 4 by 5 and B is square root of 1 by 5. So we'll put the values here. So this will be equal to square root of 4 by 5 into square root of 4 by 5 E1 plus square root of 1 by 5 into square root of 1 by 5 E2. Now E1 and E2 we can get the value from the general energy formula for the 1D potential box, which is En is equal to n square pi square h cross square divided by 2m L square. So for n equal to 1, for the ground state energy we will put n equal to 1, for first excited state we will put n equal to 2 and get the value of E1 and E2. So this will become square root of 4 by 5 into square root of 4 by 5 1 square pi square h cross square divided by 2m 1 square. Why 1 square? Because it is given that L is equal to 1 plus square root of 1 by 5 into square root of 1 by 5 2 square pi square h cross square divided by 2m into 1 square. So upon product, this will, the first term will ultimately give 4 pi square h cross square divided by 10m and the second term will give 4 pi square h cross square divided by 10m. So the sum will be equal to 4 pi square h cross square divided by 5m. So this is the expectation value of energy in the given wave function in this state. So let's check the options. Now if you look at the option, you can see that option B is matching with the result. So correct answer for this question is option B.